When wiring a subpanel, you can pass homeruns through the subpanel enclosure with the subpanel feeders, and then terminate these homeruns in the subpanel, provided certain conditions are met to ensure safety and code compliance. Firstly, consider conduit size. The conduit used to pass these conductors, including both the subpanel feeders and the homeruns, must be adequately sized to accommodate all conductors. The National Electrical Code, or NEC, specifies conduit fill requirements in Chapter 9 and Annex C. These tables provide the maximum number of conductors of a given size and type that can be installed in various sizes of conduit. You'll need to calculate the total cross-sectional area of all conductors to be installed in the conduit and compare it to the allowable fill percentage for the specific type and size of conduit being used. Secondly, think about conductor size. Each homerun conductor must be sized appropriately for the load it will serve. This sizing must comply with NEC tables such as 310.15b16, which provides ampacity ratings for conductors based on their size, insulation type, and installation conditions. Factors such as ambient temperature and the number of current carrying conductors in the conduit may require ampacity adjustments or corrections. The conductor ampacity after adjustment and correction must be sufficient to carry the non-continuous load plus 125% of the continuous load. Thirdly, what is the wire rating? The homerun conductors must have a temperature rating suitable for the environment in which they are installed and a voltage rating equal to or greater than the system voltage. Conductors are typically rated for 60 degrees Celsius, 75 degrees Celsius, or 90 degrees Celsius. The selection of the appropriate temperature rating depends on the terminations of the equipment where the conductors are connected. Equipment is commonly marked with the temperature rating of the conductors to be used. Fourthly, you must perform proper identification. All conductors must be clearly and permanently identified to facilitate tracing and troubleshooting. Color coding is a common method for identifying conductors, but it must comply with NEC requirements. For example, grounded conductors must be white or grey, and equipment grounding conductors must be bare or green. Phase conductors can be any color other than white, grey, or green. Labeling each conductor with a permanent marker or labeling machine can also provide additional clarity. Finally, think about the number of conductors. The number of conductors allowed in a conduit is limited by the conduit's fill capacity. Exceeding the fill capacity can lead to overheating of the conductors due to inadequate heat dissipation and can also make it difficult to pull the conductors into the conduit. Conduit fill is covered in Chapter 9 of the NEC. Although passing homeruns through with subpanel feeders is permissible under specific conditions, it is generally not considered a best practice. Running separate conduits for each homerun provides better organization, simplifies troubleshooting, and reduces the risk of overcrowding the conduit. If running separate conduits is not feasible, the above considerations must be carefully addressed to ensure a safe and code-compliant installation. Always consult with the local electrical inspector to confirm that the proposed installation meets all applicable requirements. Failing to do so can result in failed inspections and costly rework. Additionally, ensure that all work is performed by qualified and licensed electricians who are familiar with the NEC and local electrical codes. This helps ensure that the installation is performed safely and correctly. Remember that electrical work can be dangerous and should only be performed by qualified individuals. If you are not comfortable working with electricity, it is best to hire a licensed electrician to do the work for you. When planning an electrical installation involving subpanels and homeruns, it's crucial to perform a thorough load calculation to ensure that the existing main panel has sufficient capacity to handle the additional load. This calculation should include all existing loads as well as the new loads associated with the subpanel. If the main panel does not have sufficient capacity, it may be necessary to upgrade the service. Proper grounding and bonding are also critical for safety and to prevent electrical shock hazards. The subpanel must be properly grounded to the grounding electrode system, and all metallic components must be bonded together to create a low impedance path for fault current. Follow NEC Article 250 for grounding and bonding requirements. Surge protection is another important consideration, especially in areas prone to lightning strikes or power surges. Installing a surge protective device, or SPD, at the main panel and subpanel can help protect sensitive electronic equipment from damage. Select an SPD with an appropriate voltage protection rating and surge current capacity. All electrical connections must be made properly and torqued to the manufacturer's specifications. Loose connections can cause arcing, overheating, and even fires. Use a calibrated torque wrench to ensure that all connections are tightened to the correct torque value. After completing the electrical installation, thoroughly test all circuits to ensure that they are working properly. Use a multimeter to verify voltage, current, and continuity. Check for any short or ground faults. Document all work performed, including wire sizes, conduit sizes, circuit numbers, and breaker locations. This documentation will be helpful for future troubleshooting and maintenance. Keep a copy of the electrical plans and specifications on site for reference. When working with electricity, always follow lockout-tagout procedures to prevent accidental energization of circuits. De-energize the circuit at the breaker and verify that the circuit is de-energized before working on it. Use a voltage tester to confirm that the circuit is dead. Install a lock and tag on the breaker to prevent it from being accidentally turned on while you are working on the circuit. Wear appropriate personal protective equipment, or PPE, including safety glasses, gloves, and insulated tools. Avoid working in damp or wet conditions. Be aware of your surroundings and avoid contact with energized parts. If you are unsure about any aspect of the electrical installation, consult with a qualified electrician. It is always better to be safe than sorry. When routing conductors, avoid sharp bends and keep conductors away from heat sources. Use cable ties or straps to support conductors and prevent them from sagging. Maintain proper clearances around electrical equipment to allow for adequate ventilation and access for maintenance. Do not block access to electrical panels or equipment. Ensure that all electrical boxes and enclosures are properly sealed to prevent the entry of dust, moisture, and insects. Use appropriate sealing compounds to seal openings and penetrations. Inspect electrical installations regularly for signs of damage or wear. Replace any damaged or worn components immediately. Keep electrical panels and equipment clean and free of debris. Regularly test ground fault circuit interrupters, or GFCIs, to ensure that they are working properly. GFCIs are designed to protect against electrical shock hazards. Replace any faulty GFCIs immediately. When adding new circuits, be sure to balance the load across all phases of the electrical system. This will help prevent overloading one phase and causing voltage imbalances. Use a clamp-on ammeter to measure the current on each phase and adjust the load accordingly. If you are planning to install a generator, be sure to install a transfer switch to prevent backfeeding power onto the utility grid. Backfeeding can be dangerous and can damage electrical equipment. Follow all applicable codes and regulations for generator installations. When working with aluminum conductors, use an antioxidant compound to prevent corrosion. Aluminum conductors are more prone to corrosion than copper conductors. Use connectors and terminals that are specifically designed for use with aluminum conductors. Be aware of the potential hazards of working with electricity and take all necessary precautions to prevent accidents. Electrical shock can be fatal. Work safely and responsibly. Continue learning and staying up to date on the latest electrical codes and technologies. The electrical industry is constantly evolving, so it is important to stay informed. Attend training courses and seminars to improve your skills and knowledge. Read trade publications and websites to stay up to date on the latest trends and technologies. By following these guidelines, you can help ensure a safe and code-compliant electrical installation. Remember that electrical work can be dangerous and should only be performed by qualified individuals. If you are not comfortable working with electricity, it is best to hire a licensed electrician to do the work for you. The goal is to ensure the long-term safety and reliability of the electrical system.